Okay, the iCarly theme song brought to you by some kids in my third period class. We have, in section 3.1, we started the day today looking at these two functions on the green worksheet for 3-1, numbers 1 and 2. We noted that this one, they wanted to know what the degree was. We said it was 1 because the exponent there is understood to be 1. The number of terms was 2, and the leading coefficient is 5. The second one we're exploring further on Desmos. We're taking a look at this in standard form. We have here in yellow, okay, standard form. And I mentioned to the class that what we care about is the function's degree, whether it's even or odd. See, we're going to make a chart over here, those of you in class right now. We're going to make a chart. If the degree is even or odd, versus the leading coefficient, 5, and whether it's positive or negative. And what's 5? Positive. So here's what the graph looks like. When you first look at it, it kind of looks like a blank parabola with a weird little dent in it, right? So someone punched it in the side and dented it. So it is sort of parabolic, and what I want to explore is what happens on Desmos or your calculator when you change the 4. Let's go up here and let's backspace the 4, and let's change it to a 2. Backspace 6. Change the degree to 8. Is it changing much? When you first glance at it, would you say it changes its shape much? Not really. If I change it to a 10, it still kind of looks like that parabola with a dent in it. And what's true about 2, 4, 6, 8, 10? They're even. Okay, let's change that exponent to an odd and see what happens. In fact, if I change my 10 to a 1, is that odd? Is 1 odd? The students say, yes, 1 is odd. So I'm going to backspace. What does it become when the exponent is 1? Good. It's a line, right? So the exponent is 1, the degree is 1, and it's a line. Make it a 3. Does odd change its shape from how it looked when it was even? Change it to a 5. Change it to a 7. Change it to a 9. Is there a big difference between 9, 7, 5, and 3? It kind of changes its steepness and its up and down and how far it goes, but its overall shape, I think it kind of looks like this zigzag thing, right? This up and down S curve. And that's what an odd exponent will look like versus an even. The even ones look like parabolas, and they might have a weird little dent in them. The odd ones look like a line, kind of with 2 dents in them, right? Someone punched it from the bottom and the top, like this. All right? Sorry you couldn't see that at home. All right. So, but it's like someone punched it this way and that way and dented it twice. That's what odd does. What did I mention about the leading coefficient? What controls the leading coefficient? What about it will change how our graph might look? Yeah, the student whispered, positive or negative? Yes, positive or negative. So let's explore that a little bit. Let's go back to the original function that we had. What was it? That guy was a 4? Okay. Let's toggle back and forth between the lead coefficient, 5, being positive, which is now. Prediction for negative? Flip. Negative, not negative. Negative, not negative. Negative, positive. Negative, positive. Which one would hold the water if you poured the water in? Positive. Which one would dump the water? Negative. Okay? Even degree, positive. Even degree, negative. Comprende? And that's whether that exponent was a 2 or a 4 or a 6 or an 8 or anything even. All right? So what about odd positive? Let's check it out. Let's make the 4 a 3 again. Harder to keep up on the TI, huh? Sorry. So let's make that 4 a 3 again. Whoops. We need to make it an exponent. 4x to the third. There we go. So that's what 5x cubed will look like, with the 5 being positive. If you were climbing a mountain or skiing on this mountain from left to right, if you were the skier going from left to right, overall, would you be climbing the mountain or skiing down the mountain? As you go from left to right, you would be climbing, the student said. But if there's a negative there, would you be skiing or climbing from left to right? Skiing and screaming, because that's pretty steep, right? How could we make it less steep? 0.05, 0.005, 0.0005. Whoa, it's still pretty steep. That's because it's x cubed, and x cubed is pretty steep because you're taking it to the third power. Okay, but the moral of the story is negative makes it go downhill from left to right. Positive makes it go uphill from left to right when the power, when the degree is odd. Thank you. Okay, let me take it back to positive. Is it increasing from left to right the whole time? No, right? Here it goes downhill a little bit, right? And then it goes back up. It recovers and goes up again. Overall, it's going uphill. So in class, we're going to summarize that in a moment. If you're watching at home, I'll summarize it in the next video.